Right, so in this podcast we're going to see, we want to predict if we take two things, will they actually react or will they not react? So on your goldenrod sheet you have a list, which is known as the table of standard reduction potentials. Okay, and notice that all of these have electrons on the left hand side. So electrons are being added or they're being gained. Alright, so because Leo says grr, because they're being gained, all these are listed as reductions. Okay? But we know that two things can't be reduced and they react. Something is always reduced, something is always oxidized, because whatever thing is being reduced is gaining electrons from the thing that's losing them. Alright? So you can't have two things can't be reduced at the same time. Two things can't be oxidized at the same time. You have to have one of each because those electrons are being transferred, and that transfer of electrons is what electricity is. Alright? So all these are listed as reductions. To know if something happens, something above, alright, so something up here has to be reduced, while something below has to be oxidized. So there's an easy way just to predict whether something is possible or not possible. Alright? So what we're going to do is, we're going to look at our two reactants. So we have iron plus 3. So I'm going to come over here and find iron plus 3. And I find it's right there. Alright? I just highlighted it. Magnesium, just by itself, so we're going to find magnesium is towards the bottom, but notice magnesium element is on the right hand side, not the left hand side. Alright? So if I connect these dots, I'm just going to connect them with a blue line, I have a line that goes from northwest to southeast. Okay, so we're just going to call this the northwest southeast rule. Northwest to southeast. If something goes from northwest to southeast, or from top left to bottom right, it occurs, or it happens. You might even say it's spontaneous. But we could make a battery out of iron ions and magnesium metal, because iron would be reduced and magnesium would be oxidized. Okay? So we're going to say, do these happen? We're going to say, yes, this first one occurs. I'm going to erase that line, and we're going to go to our next one. We're going to use different colors of highlighter. So we have aluminum plus 3. So I'm going to come over here and find aluminum. It's down here towards the bottom. And there's aluminum plus 3 on the reactant side. And then I'm going to look for zinc. And zinc, oh, it's actually right above. Alright, so if I connect these lines, notice I am not going from northwest to southeast, but I'm going from northeast to southwest. So this is a reaction that will not occur, okay? Or just no. These two things won't react. What's true is zinc would rather be reduced, and if we react these two things, zinc would have to be oxidized. So just inherent in its chemical makeup, it will not be oxidized by aluminum ion. Okay? So if we look at our next one, let me get rid of that line. Put a blue highlight. Lead plus 2. So if I need, there's lead plus 2 right in the middle. And we're going to look for copper metal. Copper metal is over here on the right. So again, if I draw a line, we find that that will not happen. Right, big no. Alright, and then lastly, bromine, right there, and nickel right here, and notice I have a line like that. So yes, we could react these two things to form a battery. So our middle two examples, we could not make a battery out of lead ion, copper metal, but we could make it out of bromine gas and nickel metal, right? So again, remember the northwest-southeast rule. If you connect your lines and they have an angle like that, they react. If they have an angle going the other way, that is no bueno. Alright, so anyways, that is predicting whether two things will react or not.